Okay, so for this example, we would be designing our section. So, ito na yung design part natin. And if we are to design, we would be following these steps right here. So, meron tayong method 1 and method 2. And ang similar sa kanila would be to get the load combination and to assume KL over R. And that is to be 50. Okay, so with that, we would be following those procedures right there in this certain example. So once again, ang step 1 natin would be to compute for the load analysis. I mean, load combinations, I should say. Okay, I'm sorry. So, load combinations. Okay, so for our load combination, that is to be, by the way, if you can remember what I said earlier, na kapag magdi-design tayo, it is better for us to use LRFD in selecting our sections. Then after selecting our sections with LRFD, we would be analyzing them with ASD. Okay, so with that being said, our LRFD, so load combinations would be PU is equal to 1.2 DL plus 1.6 LL. So this is to be 1.2 times 600 plus 1.6 times 1000. So solving for that, our value would be 1.2 times 600 plus 1.6 times 1000. So our value for PU would be 2320 kilonewton. So this would be our load combination. By the way, meron pa tayong isang possible na outcome ng ating load combination, that is to be 1.4 times DL, and our DL would be 600. So solving for this, that is to be 1.4 times 600, so 840. And as you can see, 840 kilonewtons is a lot less than 2,320. So from that, we would be using 2,320 as our load. So that is to be for step 1. So tapos na tayo for step 1, ano? And for our step 2, assume KL over R. So in my case, I would want my KL over R to be 50. So, ayan, na-assume na natin ang ating KL over R. So, eto, sa step na to, mag-method 1 na muna tayo. So, method 1, using method 1, if you can remember our method 1, it is like this. So, we would be solving for the critical buckling stress. So, and pag na-solve na natin yung critical buckling stress na yan, we would now be solving for AG. And solving for AG, which is the area gross, we would now be selecting our trial section. Then after that, we would be analyzing if our section would be adequate for the loading combination that we have acquired earlier. So for method 1, that is to be, so step 3. Yellow natin para, okay, so step 3, that is to be FCR is equal to 0.658 Fy over Fe. So Fy over Fe times Fy. Oh, by the way, meron na ba tayong Fy? So, lagyan ko na note dito. So, for our Fy for A992 steel, so this was our example earlier. So, this is to be 345 megapascals. And for our Fe, so our Fe is equal to pi squared times E, which ano ba yung E natin? That is to be 200,000 divided by slenderness ratio squared, and we have assumed our slenderness ratio to be 50. So 50 squared. So from that, ang ating Fe would be pi squared times 200,000 divided by 50 squared. So our Fe would now be equal to 700 289.57 megapascals. Okay, so substituting these known values right here to our formula for FCR, that is to be 0.658 raised to 345 divided by 789.57 times 345. So our FCR would now be equal to 0.658 raised to 345 divided by 789.57. So equal sign times 345, that is to be 287.34. So 287.34 megapascal. So that would be our critical buckling stress using method 1. So for us to get the area required, so AG is equal to PU over phi Fy. Okay, so substituting known values, our PU would now be equal to 2320 kilonewton. So ito yung loading combination natin kanina. So divided by phi, and our phi would be 0.9, and our Fy would, oops, mali, Fy. Dapat FCR pala yan. So this is to be FCR. Okay, so if that is the FCR, ito is 287.34 megapascals. Naka-kilonewtons pala to, no? So we must convert it first to newtons. So that is to be times 10 raised to 3 para maging newtons yan. So that is to be newtons per kilonewtons. Okay? Ayan. So solving for our area gross, that is to be 2320 times 1000 divided by 0.9 times 287.34. So our area gross would be 8971.18 millimeters squared. So this is to be for your area gross. And as for our next step, we would be selecting our trial section. Okay, so what we would be doing next is to select the lightest W14 section with this cross-sectional area right here, or yung mas malaki naman ng onte, 8971.18. Okay, so I would now be going to this database right here, and since W14 ang kailangan natin, I would be searching for W14. So find next. Wait lang, hanapin ko muna yung W14 natin. So eto, na-highlight ko na siya talaga yung mga W14 natin dito. Okay, so instead of us converting our area right here into inches, so naka-inches, naka-millimeters kasi ito, and nasa table kanina nasa inches, we can actually convert this into inches. Then check natin dito kung ano yung ating mga area. So ito. So it would be this, or you can just do this instead. You can just scroll to this part right here up to this point. So ito na yung ating mga area, no? So i-highlight ko lang na ibang color. So this would be the areas na in millimeters squared. Okay, so ang area natin kanina is 8971. So maghahanap tayo dito ng malapit-lapit sa 8971. And may nakita na ako, ito, catchy. So 9,100. So anong section to? If you are to look at it here, it is W360 by 72 in metric. And in English, it would be W14 by 48. So ito yung gagamitin nating section ngayon. W14 by 48. So kapag itong 9,100 yung ating ginamit na area. Okay, so from that, lista natin yung mga parameters nito. So, balik tayo sa open board. So, next page na tayo, no? So, for the analysis part, so mag-analyze na ulit tayo. So, okay, now that we have our section already, which is W14 by, nakalimutan ko ulit. So that is W14 by 48. Okay. W14 by 48. So using these parameters, ang kailangan natin dito would be A. So the area gross and the Rx and Ry. Okay, so for our area gross, ba't ko ba sinulat ng ganyan? So for our area gross, that is to be, nakalimutan ko, no? 9,100. So 9,100. And as for our Rx and Ry, that is to be 149. So this is to be 149. And this is to be 48.5. So Ry natin is 48.5. And as you can see here, Ry has a less radius of gyration. So yan yung gagamitin natin for our slenderness ratio. So from that itself, we would be checking the adequacy. So check adequacy. Okay, so from that, letter A tayo. So slenderness ratio. So for the slenderness ratio, KL over R. So KL over RY. That is equal to, ano yung K ulit natin kanina? So kung ito pinned and ito fixed, so that is to be 0.7. So ito pinned fixed ay 0.8 I should say. So our K right there would be 0.8. So 0.8 times what would be the length? That is to be 4,500 mm divided by Ry. And our Ry would be 48.5. So from that, our slenderness ratio would become 0.8 times 4,500 divided by 48.5. So that is to be 74.226. So 74.226. So after getting the slenderness ratio, so lagyan natin ng A, and B natin ngayon would be FE. So FE is equal to pi squared E. So rektahin ko na 200,000 divided by KL over R squared. So divided by anong KL over R natin, that would be 74.226 squared. So from that, ano yung sagot natin dito? That would be pi squared times 200,000 divided by 74.226 squared. So that is to be 358. So 358.276 megapascals. Okay, so next up, after solving for FE, we would now be solving for FCR. But for us to solve for FCR, check muna natin yung ating limiting factor. And yung limiting factor natin once again is, layo naman lalakbayin natin. Ito pala, 4.71 times the square root of E over Fy. So solve muna natin yon. So for our limiting factor, lagay ko lang dito niya yellow. So 4.71 square root of E over Fy, and our E is equal to 200,000 over Fy. Ang Fy natin is 345. So this is equal to 4.71 times square root of 200,000 divided by 345. So that is to be 113. So 113.403. Okay, so if that is to be our limiting factor and ang slenderness ratio natin is 74.226, so lagay tayo ng conclusion dito. Thus, 74.226 or the slenderness ratio is less than or equal to 113.403. And kapag less than siya or equal to, we would be using this formula right here. So, kasi less than or equal to siya. Oh. So, 0.658 Fy over Fe times Fy. So, from that, FCR, saan na ba yun? We can now solve for FCR, which is, so, is equal to 0.658 raised to Fy over Fe. So, our Fi would be 345 and our Fe would be 358.276. So, ito, 358.276 times Fy, which is 345. Okay, solving for this is to be 0.658 raised to 345 divided by 358.276. So, baba times 345. So, your flexural buckling stress would be 230.558 megapascals. So, for us to solve for the value of Pn, so Pn natin would be, ano na yon, Ag, what would be our Ag? 9,100. So, 9,100 times 230.558. So, 230.558. So, basically, guys, ito lang siya, no? Pn is equal to AgFCR. So, ayan lang yan. Okay, so solving for this would become 9,100 times 230.538. So, this would be in newtons. And if we are to divide this by 1,000, this would be in kilonewtons. So, 2,097.9 kilonewtons. And if that is to be Pn, para makuha natin yung Pu natin in LRFD Pu is equal to 0.9 or phi Pn, and our Pn would be 2097.9 kilonewtons. So from that, 0.9, so 0.9 times 2097.9, so that is to be 188.11. So lagyan lang natin siya dito, no? So by analysis, using W14 by 48. So, W14 by 48. Pu is equal to, or the design strength of W14 by 48 is equal to 1888 kilonewtons. So, 1888 kilonewtons. So, this is to be the design strength of the section. Pero ano ba yung loaded combination natin? I mean, load combination natin. So, that is to be 2,320. So, from load combination, Pu is equal to, nakalimutan ko, 2,320. So, 2,320 kilonewton. So, if this is to be bigger than this, so, ibig sabihin, this would fail. So, mali to. Kailangan pa natin ng mas mataas. So, ang conclusion natin dito, W14 by 48 is inadequate. And if that is to be the case, i-check nyo yung next na pinakamalaking section and mag-analyze na lang ulit kayo. And in our case right here, ano ba yung mas malaking next? So, ano yung mas malaking next natin? That would be W14 by 53. So, etong W14 by 53 na to, i-analyze nyo ulit and kung adequate na siya, Meaning, yan yung lightest section na pwede nyong gamitin. So, that is to be for method 1. So, kayo na yung magtuloy nito. Basta kung inadequate to, select next section, then analyze. So, if adequate na, edi yun na. So, that is to be for method 1. Oops, di nyo pala nakita yung pinagsusulat ko. So, eto, if your section is to be inadequate, select the next section and analyze. Okay, so that is to be for method 1. And for method 2, kung naalala nyo man yung method 2 natin, mag-solve lang tayo ng R. So we would be solving for R. Then select trial section, then analyze. So ngayon solve natin yung R na yan. So next na naman tayo, method 2. So this is to be for method 2. So our KL over R is equal to 50. Yun yung inassume natin kanina, no? So KL over R is equal to 50. So if that is to be the case, ito yung inassume natin, we would now be solving for R. So solve for R. And from that, our K, so lagay tayo dito ng note. So K is equal to 0.8. Ito yung pinag-usapan natin kanina. And our length would be 4,500 millimeters. Teka, tama ba ito? Nakalimutan ko na. So yes, 4.5 meters. So 4,500 millimeters ang ating length. So for us to solve for R, so that is to be K. So 0.8 times 4,500 divided by 50. So cross multiplication lang, no? So that would be the value of R. So solving for that, our answer would now be equal to 0.8 times 4,500 divided by 50. So that is to be 72. So 72 mm. So now that we have solved for our value of R already, we would be selecting the section from our database. So ang database natin would be this, and ano daw yung ating hahanapin, yung mayroon siyang R minimum na 72 mm. So from that, dito sa dalawang to, sa columns na to, maghahanap tayo ngayon ng ating mga trial section. Oops, masyadong madilim. Liwanagan natin. So yan. Maghanap tayo ng R minimum na merong 72 mm. So alin ba dito may 72 mm minimum? So if you can see here, etong mga to hindi po pwede kasi 63 ito. So from that, we would be choosing this. Itong 94 natin mas mataas sa 72. Okay, so from that, I would be choosing this, which is W14 by 90. So, try. So, lagay natin dito. Try W14 by 90. Okay, so ano ng ating next? So if that is W14 by 90, check natin ng ating A and R. So ano ba yung A and R natin dyan pala? So ang gross sectional area natin would be 17,100. And for our RY, huwag na natin kunin itong RX kasi hindi lang natin magagamit. So ang RY natin is to be 94. So ano na ulit yun? 17,194. So AG 17,100 millimeters squared. And for our RY, that would be 94 mm. So using these parameters, we would now once again check for adequacy. So dito na lang tayo para hindi sayang ang ating space. So dito. So checking for adequacy. Magandang color. Sige, yellow na. Didiretso na natin. So for A, slenderness ratio. So KL over R. And ano ba yung KL over R natin ng section na ito? So for our KL, that is to be 0.8 by 4,500 still, divided by what would be our RY, so that is to be 94. So solving for this, 0.8 times 4,500 divided by 94. So that is to be 38.3. So that is to be 38.3. Yeah, that is to be our slenderness ratio. Okay, so ano bang next natin? We would now be solving for FE. FE is equal to pi squared E over KL over R squared. So, idiretsa ko na. Pi squared times E, which is 200,000 megapascals. So, we would be dividing this by, pangit ng linya ko. Ito na lang, para mukhang instructor naman, okay? Divided by KL over R squared, and our KL over R would be 38.3. So, 38.3 squared. So, solving for our value of FE, so that is to be pi squared times 200,000 divided by 38.3 squared. So, equal sign. Okay, so that is to be 1345. Laki 1345.65 megapascals. So, MPa. So, the next thing that we should do is to solve for the critical buckling stress. So, na-solve na ulit natin to kanina, yung 4.71 times Fy over Fe. So, parehas din lang yan, no? Kasi hindi naman napalitan yung Fy and Fe natin. That is to be 113 ata yun eh. No, 113.403. So, ito siya. Hindi ko na kinompute para hindi sayang oras. So, 113.403. And our KL over R is equal to 38.3. So, it is still less than or equal to 113.403. So, with that being said, our FCR would still be 0.658 times, raised to Fy over Fe. So, ang Fy natin would be 345 divided by our Fe. Ano Fe natin? 1345.65. Then, our answer would be multiplied by our Fy 345. So, from that, our FCR would now be equal to 0.658 raised to 345 divided by 1345.65. So, equal sign times 345. So, our FCR would now be equal to 309. So, 309.9 na lang. 0.9 megapascal. So, for us to get the value of PU, rektahin na natin. So, for PU, which is VPN, PU is equal to VPN. So, this is in LRFD. That is to be phi. What is to be phi? That is to be 0.9. And for the value of PN, that is to be AG times FCR. And our AG is 17,100. So, 17,100 millimeters squared times FCR. That is to be 309.9 megapascals. So, from that, our PU would now be equal to, so this is to be in LRFD, 0.9 times 17,100 times 309.9. Tama ba? Okay, so this is to be in newtons. So, we would be dividing this by 1,000 to convert it into kilonewtons. So, our PU would now be equal to 4,769.361 kilonewtons. And if we would be comparing this to our factored load, so ito, hulaan ko na, it is way bigger than that of our load combination. So, 2,320. So, 2,320 kilonewton. So, if we are to use this method in this particular problem, masyado atang over-design. Halos doble yung capacity, oh. And if that is to be the case, para naman mas maging economical, pipili kayo ng mas mababang section as compared to this W14 by 90. So, ayun. Ito yung method 2, yung kanina yung method 1. And yung method 1 naman natin kanina is naging inadequate because it is less than 2,320 kilonewtons. So, ayun. Magre-resolve na lang kayo na magre-resolve. Oh, by the way, hindi ko pala sinabi dito kanina, no? Ito yung over-design nga to, kaya pipili na naman tayo ng mas maliit na section. So, okay. So that would be it for this pre-recorded lecture. If there are any questions, feel free to message me. Okay, so good luck. Study well.